Hello, my name is Kaixi Chen and that's my lab 1 in constant motion. So the purpose of this lab is to observe the motion of an object when it's moving at constant velocity and use a computation model and computer software to predict and analyze the motion. So the hypothesis that is set is that when the net force is zero, the object will move at a constant velocity during the time interval. So the fundamental theorem that I am using in this lab is Newton's first law and Newton's second law. Newton's first law stated that object in motion will stay in motion unless a force is acted on it to change that. And Newton's second law, it's basically the velocity update equation that Vf equals Vi plus F net over m times delta t. Newton's first law is used to ensure that the object can move at a constant velocity since the net force is zero because there's no other force acting on it. And Newton's second law is used to calculate the new velocity. And the results of my lab is my object's motion basically matches the predicted motion from the computer, but I can clearly see how the outside force like air resistance and the wind is affecting my motion as well. So I did my lab with my drone and it has the function to lock direction and speed so it can fly at a straight line with constant velocity. And I used my camera to record the motion and analyze it in Tracker. Then I used GlowScript to create a Python simulation. So I first measured the distance and time that it will take for the drone to fly, and then I used the equation delta x equals vt to find the average velocity of the motion. It's negative 1.6 meters per second. Then I used Tracker to analyze it, the position of it frame by frame, and here it is. That's in Tracker, and you can see that's the coordinate and that's the origin. Since the drone is flying to the left, and so all the velocity and position are negative. And then I mark the average position of the drone at each frame. Then it will generate a graph like that. Here's my coding. So this part is just create a ball and then graph the position versus time. That here I have the initial velocity, and that's each delta t. That's given from Tracker, and that's the total amount of time. It's a 4.27 second, and here it calculates the velocity using Newton's second law, and that's the position update function. And when I run this, you can see that's the path of the object, and that's the position versus time graph. That's the velocity versus time graph. You can see it's a straight line for velocity, and that's it's like a linear line for position versus time. And those are my graphs for that's my position versus time graph, and the blue one is the real one from the lab, and then the red one's the simulated version. And then that's my velocity versus time graph. You can see that it basically matches until like after 3 seconds, and the position's a little off. And the velocity versus time graph is a little bit bumpy. Like you can see that the velocity is like jumping around, but it basically shows it's a flat curve, and the computer one is just a straight line. So the conclusion, though, like the motion of the object basically matches a predicted motion from the computer model, the velocity graph is still a little off. I think that's because of the air resistance and the wind that is affecting the object. And the orientation, the object's moving to the left, that's why everything's negative. And the place that I mark, the average location of the object, can also affect the motion as well, because it's kind of hard to mark the exact location during each frame. But overall, the velocity still shows a flat train line and is close to negative 1.6 meters per second as predicted. So if I have more time, maybe I will try to fly indoor to avoid the wind, and I think that result will be more accurate. And that will be all. Thank you.